In this video, we are going to discuss the last topic of chapter 1, irrational numbers. We are going to prove root 5 is irrational number. So, the same method can be followed for root 2 and root 3. And we have to know that root 2 is the first found irrational number. We are going to prove root 5 is an irrational number using proof by contradiction. You should understand what contradiction means. Contradiction means if a particular sentence is given or a statement is given, you should make a wrong assumption on that statement and you should try to prove it logically. If you are not able to prove that, then the given statement will be true. The same method we are going to use in order to prove root 5 as an irrational number. So for that we can complete in 4 steps. Step 1, you are going to assume it root 5 as a rational number. So when the root 5 is going to be in rational form, it will be in the form of p by q. So p and q are co-primes and they are integers, hence they will have a common factor as 1 only. Hence the value of HCF is 1. In step 2, we are going to rewrite p in terms of q. Hence we get the star equation as p is equivalent to root 5 times of q. And squaring on both the sides and solving it, we get 5 times q raised to the power 2 is equivalent to p raised to the power 2. From the equation 2, we can conclude that p square is divisible by 5 now. In step 3, we also know that p square is divisible by 5, hence p is divisible by 5. So it is going to have 5 as a multiple in it. Hence we can write p as 5 times c, where c will be always any integer. And then you have to substitute that particular p value in the star equation, which is p is equal to root 5 times q. So when equating these both and squaring on both the sides and solving, we get q square is equivalent to 5 times of c raised to the power 2. So now we find that q square is divisible by 5 as we found in the previous step. Now q is also divisible by 5. In step 4, we find from the equations 3 and 4, we are able to conclude that p and q are having the common factor as 5 also. But in the first step, we have assumed that p and q are co-primes, hence they should not have the common factor other than 1. Now 5 is becoming divisible by p and q, hence it is also going to be the factor of p and q. So we are going to have 2 factors here. Hence, the assumption we have made is wrong. Now, root 5 is an irrational number. It is proved. Now let us prove the next question. So it says 5 plus 2 times root 7 is an irrational number. We have to prove that. And they have also given root 7 is irrational number. For that, we can complete in 2 steps. Step 1, you are going to use proof by contradiction. So 5 plus 2 times of root 7 is said to be rational. We are going to assume it. And so it will be in the form of p by q. On equating this 5 plus 2 times root 7 is equivalent to p upon q, we can bring the rational numbers and irrational numbers separately. So the left side has root 7 and the right side p minus 5 times q divided by 2 times q is said to be rational number. Now, left side and right side are not equal. Yes, it is not equal because right side is completely rational number and left side is irrational number. It is already given in the question. So, we can see that both the sides are not equal because this side is irrational and the other is rational. Hence, our assumption is wrong. Now we will prove that 5 plus 2 times root 7 is irrational number. So let's discuss few properties of irrational number. The sum of rational number and irrational number is irrational. And the difference between rational number and irrational number is irrational. The product and quotient of a rational with an irrational number is a irrational number. So with that, we can conclude that if you find a single irrational number, you can get an irrational number. Look into few examples that I have given below. So 6 plus root 5, 7 minus root 7, and these are all the examples of irrational number. And look into it, minus root 3 is irrational, but root minus 3 is complex number. That is a different topic, but as of now, minus root 3 is irrational number. Let us see one example to understand the concept better. They have given 2 root 125 plus root 20 divided by 3 times root 5. We are going to find this number is irrational or rational. On solving it, we find the value to be 4, which is rational. So, whenever you find the root numbers, try to solve it and bring it to the simplest form to make a confirmation whether it is irrational or rational. We have completed concepts in chapter 1.